The next type of function we're going to take a look at would be quadratic functions. And the graphs of a quadratic function are called a parabola. And again, we're going to define all of these vocabulary words before finding them and graphing our parabola. So first, they want the equation for the axis of symmetry. And the axis of symmetry is the line that divides your parabola in half. Remember, it cuts the parabola in half, kind of like your nose cuts your face in half, where everything is the same on both sides. So everything on both sides of this axis of symmetry are the same. Your vertex is going to be your maximum or your minimum. Your roots, zeros, also known as solutions, are going to be your x-intercepts. Now, for a parabola, you can have 0, 1, or 2 x-intercepts. When we were looking at linear functions, we only had one x-intercept, and we always had it. But parabolas, because they're U-shaped, they can be completely above or below the x-axis. They could be sitting on the x-axis, or it could cross the x-axis twice. So we're going to talk about those different types of examples. The y-intercept is where it crosses the y-axis, same as linear functions. Maximum or minimum point, we already said that was your vertex. Domain is your x values, while range is your y values. And then remember, increase means going up, decrease means going down, and when you do this, you are going to read it like a book. Okay, so let's go ahead and get started. The easiest way to graph a parabola is going to be to use your calculator and to use the table function. So I'm going to go to my y equals menu. If there's anything typed into your y equals menu, go ahead and clear it out. Now I'm going to type in my function. So I have x squared plus 2x minus 3. First I'm going to look at the graph just to kind of check it out and see what it looks like. So it looks like this. Now I'm going to use my table to graph. Alright, I'm going to go from, let's see, I'm going to go from -4 to +2 because all of these y values will fit in my y value window. So I have -4, 5. I'm going to plot that as a coordinate point. Remember that points on a table correspond to coordinate points. So x equals -4, 1, 2, 3, 4, up 5, 1, 2, 3, 4, 5. -3, 0, 1, 2, 3, up 0. -2, -3, over 2, down 3. -1, -4, -1, 1, 2, 3, 4, 0, -3, over 0, down 3. 1, 0, over 1, up 0. 2, 5, over 2, up 5. Right here. So now I'm going to connect these with a smooth line. And a parabola is always going to look like a U or an upside down U. You can tell from the function if it's going to be a U or an upside down U by looking at your A value. Remember, when A is positive, it's going to look like a smiley face. Positive people are happy. When A is negative, it's going to look like a sad face. So because my A value was a +1, it's going to look like a smiley face. Have your little eyes right there. Okay. Getting started with our vocabulary. So first, number 1 wants the equation for the axis of symmetry, and this equation is not given to you on your formula sheet, so it's going to be something you have to memorize. The equation for the axis of symmetry is x equals -b over 2a. And I like to remember that that's the x value of the vertex by just writing out vertex in front of it with the big X. That reminds me that it's the x value of the vertex, which is also your axis of symmetry. I'm going to define my a, b, and c of this function before moving on. My a value is 1, my b value is 2, and my c value is -3. And then to calculate my vertex x coordinate, also known as my axis of symmetry, I'm going to plug in my b and my a value. So I have x equals negative 2 over 2a, and I get negative 2. So x equals negative 2, negative 1. Sorry, x equals negative 1. That's why you don't do math in your head, you use your calculator. Negative 2 divided by 2 is negative 1. So my axis of symmetry is at negative 1, which makes sense because if I divide this parabola in half right there, it's the same on both sides. Number 2 wants the coordinates of your vertex, and you can find your vertex on the graph. It's right here. It goes, your axis of symmetry always crosses through your vertex. So it's at the point negative 1, negative 4. You can also use that using your table. We said the axis of symmetry was at negative 1, and you can see that if I'm looking at the point negative 1, negative 4 right here, everything is the same on both sides of this point. So if I go up 1, it's negative 3. If I go down 1, it's negative 3. If I go up 2, it's 0. If I go down 2, it's 0. If I go up 3, it's 5. If I go down 3, it's 5. So that's the easiest way to find your vertex from a table, and that works all the time. So my vertex for this function would be negative 1, negative 4, which we can find on my graph or looking right at my table. Number 3, they want the roots or the zeros or the solutions or the x-intercepts, 4 different ways to ask the same question. To do this, you could factor it or use the quadratic formula. I'm going to do both as a review. So to factor this, I would draw my x. I would put a times c at the top. So negative 3 at the top, 2 at the bottom. I have to find two numbers that multiply to negative 3 and add to 2. So that would be positive 3 and negative 1. 3 times negative 1 is negative 3. 3 plus negative 1 is 2. So then I'm going to write this out as x plus 3, x minus 1. When a equals 1, you can be done, but I have to solve for x. So I'm going to say x plus 3 equals 0. Draw my line, subtract 3 from both sides, x equals negative 3. Do the same thing for my other factor, x minus 1 equals 0. Add 1, x equals 1. You can also see that up here. Crosses the x-axis at negative 3 and positive 1. Easiest ways to see it. You can see it in your table by looking for when y equals 0. Y equals 0 when x equals negative 3 and when x equals 1. That's why it's called your zeros. It's when y equals 0. You could also use the quadratic formula. Remember, your quadratic formula is x equals negative b plus or minus the square root of the quantity b squared minus 4ac all over 2a. It is given to you on your formula sheet, but I'm going to do it really quick. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Type that into the calculator. Alpha y equals enter. Negative b plus or minus the square root of b squared minus 4ac all over 2a. I get 1. Go back, do the minus, and I get negative 3. So no matter what way you do it, you get 1 and negative 3. When you look at the graph, it crosses at 1 and negative 3. Number 4 is your y-intercept. Your y-intercept is always when x equals 0. So you could look again at your table and find when x equals 0. When x equals 0, y equals negative 3. Or you could look at your graph. Where does this cross the x-axis? It crosses, the y-axis. It crosses the y-axis right here, which is negative 1, negative 2, negative 3. Number 5 is your maximum or minimum point. And what they mean by that is, do I have a maximum or a minimum? You're going to find your vertex. My vertex is right here. It's at the very, very bottom of my parabola, meaning that it's going to be a minimum. Your domain is all your possible x values. So again, remember your domain, you're going to be looking at your x-axis, and I'm going to follow this. First of all, this could go on forever and ever and ever. Forever and ever and ever. That way, forever and ever and ever and that way, which means it goes in the x direction both ways forever and ever, or negative infinity to positive infinity, or you could say all real numbers. The range for this one's going to be a little bit different because it never goes below this point. Everything is above that point, which is -4. So because it's always above -4, it's going to go from -4, which is included, to infinity. Remember, we use a bracket when the point is included. -4 is included in that. And a parenthesis when it's not included, or infinity we always put in a parenthesis because it's not a real number. So -4 to infinity. This starts at -4 and goes up forever. Number 8, the intervals where the function is increasing. So I want to know when my finger is going up. I'm going to read this like a book. I'm going down, 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 down. I hit this point, and now I'm going up, 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 up. So I'm going up starting at -1. So this we're talking about x values. So your intervals are always going to be your x values. Interval equals x value. I got that question a lot on your mock EOC when they were talking about the interval for the average rate of change, and they gave you two numbers in brackets like this, and they said, what's the average rate of change between those 2 points? And I got the question a lot, well, Miss King, that isn't a point on the graph. Well, that's because they say they want the coordinate point for when x equals 1 and when x equals 3 and the difference between those. Now we're going to go over average rate of change, but it's really important that you know that an interval is only x values. So my x values for when this is going up, it starts going up right here, which would be -1 to infinity. It's decreasing from negative infinity way out here. It's going down, 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 down until it hits -1. So from negative infinity to -1, it's going down. That's all we need to know for parabolas. Next, we're going to talk about exponential functions.